Hello, everyone. I think I unmute myself. Okay. All right, so I will put this, make it greater. All right. So hello, everyone. Thank you for attending the third day of our bootcamp. So my name is Eleanor. I am a final year of PhD in biostatistics at USC. So today I'm very happy to walk you through some on the topics on like, data wrangling, and I will touch a bit on how to use HPC. I'm not sure if you guys have been using it before, but I've been finding it very useful throughout my PhD. I'm sure other students, like graduate students, will benefit as well. Okay, and then if you guys have any questions, feel free to speak up, and then we can talk about your question at any point. To move forward. Wait. Wait. Okay. Right. So today's goal is we will learn about in the previous 2 days, I know you guys have been learning with Dr. Street on like R basics about like making plots using either ggplot or base R. And then today we'll go to dive into how to do data wrangling with the dplyr R package. And then we'll have many examples that will show you later on. There are other like practice examples. I probably don't have time to go through them all, but we'll post these slides on the GitHub page so you guys can look over those after class. And then I'll spend a little more time on how to use R on the HPC, or what's called the cluster. And then throughout today, I'll use this data set called diamonds. That's part of the data sets from ggplot2 package. So hopefully you guys have everything installed. Like if you have like tidyverse installed, then that's automatically will load the ggplot2 and dplyr. So otherwise, you have to install the package first. All right. Okay, and then so first of all, so what is data wrangling? What does this term mean? Well, to give a textbook version of the definition, like this is what the Wikipedia has been saying. So data wrangling is the process of transforming and mapping the data from one raw data into another format with the intent to make it more appropriate and valuable for a variety of downstream purposes, such as analytics. Well, that's pretty, there are a lot of things to digest, but if you put into a layman language, so what it is really is, so we're trying to do transformation on the data itself so that to make it easily accessible and readable. And the package we're talking about today will be very good at helping us to do this all kinds of transformation you pretty much need in the data analysis. So like I said, I'll use this data set, for example, this diamond data set from ggplot2. So here I'm loading the library of ggplot2 and then call this data, this diamond. If you have R open, you can also type those code on yourself. So these diamonds, you can print it out. And then this is in the data structure called table. So that's the data structure from dplyr R or tidyverse. You can print it out and see. So this is a data set for about like 53,000 of the diamonds. And those columns are like their characteristics like price, color, clarity. There are like 10 variables for each one of those observations on the row. Okay, and then so I'll give you like two other ways to show this, to look at this data set. So this is another function, it's called a glimpse, the glimpse of diamonds. So you can see, so here, this is every characteristics will be printed out as per row instead of, previously that's on the columns. That's what this data frame has been, this is data frame itself. And this is like a summary put into row. And then also it will shows up the type of every column, like the caret, it's a numeric value, and cut, it's a factor value, that's an ordinal factor, and others like integers in the price. So that's another way to look at the data. And then, so if you want to have a like overview of what each variable has, the mean, the median, max, minimum, this is a very nice function using summary to call on this data set, and then that will print out those for numerical values, that will print out the mean, those those summary stats, and for ordinal like factor variables like cut or clarity, those will print out what are the factor levels, and then the count corresponds to each one of those levels. All right. And then, so going into this dplyr package. So why do we need this kind of like operation? So typically when we're doing data analysis, the first step we'll do is trying to explore to get to know your data and prepare your data set for analysis. So for example, we want to create summary statistics for those variables and also for those like individual observations on the rows. For example, like other things that I want to do, like creating new variables. Like for example, we can also, we need to filter out some individuals that doesn't meet the like certain criterion. Maybe, want to keep the individuals with the like elder age, like greater 60. And the other things is we usually will do multiple things at the same time. For example, you want to do subsetting to keeping those which rows you want to keep. You want to create new variables, and you want to only keep some of those variables, so like extracting. So multiple steps usually can happen at the same time. And the dplyr package is really handy in terms of will provide you a very clean and nice syntax, a programming language to perform these operations. All right, and then, so the most important functions provided by the dplyr package is, so those are, so what I listed here is 5, what we call this verb function. So that's select, filter, mutate, summarize, group by. Those are very commonly used in a day-by-day data analysis. Since I have been using like dplyr packages for long. So I will get into each one of those, and then I'll have like a practice problem for you to try it out yourself. We probably don't have time during the class, but you can always go back and see how each function has been doing. All right, and then so if you don't have the dplyr or tidyverse installed, you have to install it first. If you have, you can in your R, open your R or RStudio, load the package, library tidyverse, or you can load dplyr only, because tidyverse is like a composite package for multiple other R packages as well, so like ggplot2 or dplyr. All right, and then okay, we'll start from the first verb. So the first thing is let's say we want to subset this data frame by column. So the select function is to allow you to select those columns from the data frame. So the syntax here is, so the first argument is select X, the first argument is a data frame, and Y is the names of those variables you want to select from your data frame X. And then note that this Y, it doesn't have to be one name. You can select multiple names at the same time. And also you can select by their numerical positions, like 1, 2, 3. And then, so the example here is, so let's say we have this diamond data frame, and then we want to select 2 columns or 2 variables. It's called caret and price. And this is the code that you will do to select those 2 columns. I see, is there a question? Okay. All right. And then, so yeah, so the next is a like example that if you want to try it out yourself, like say, we want to create this data frame where it only contains 4 columns. Those are like 4 Cs. like cut, color, clarity, caret. You can try it out yourself, maybe take a minute or two. But I can provide the answers here. It's just very simple. It's just put out what the columns names after the data frame on this line code and assign it to a new data frame. It's called diamond 4C. All right. Okay, so that's the first verb, and the second verb is select. So select will let us to subset the data by column wise, and the next thing that we were interested in is how we can subset the data from row wise, like to filter those individuals that meet some logical criterion. So this is the syntax. The X again, that's the data frame, and then you want to extract rows from the X where Y is like a logical, it's a logical code that you can specify to say, where Y is true. Well, okay, so and then the example, so let's say for the diamonds data set, we want to keep those diamonds, those observations with the price that's under $2,000, all right? And then so here, this is you specify the data frame, and then this is your logical statement. It's the price less or equal to 2,000. And then here, this will be the data frame that's after the filtering. All right. And then there's another example that you can try it out yourself. So here, this is a filter. They select to subsetting the data frame to those diamonds that are both ideal in cut and internally flawless in the clarity. And then if you want to try it out yourself, you can maybe later after class. So we can go through this very quick. Right, so here this is you can specify multiple logical statement in the meantime and use this and operator. So this is clarity is this AF equals AF and then cut equals ideal. So this is how you create this like a new data frame that only contains those fine diamonds. All right. Okay, and then so the previous two, we're not creating any new variables. It's just only subsetting based on existing values. So of course we can do to create new variables or even change existing variables as well. So for example, for here, this mutate function is allows you to add a new column to the data frame X where the syntax here, again, X data frame, Y is where you want to create, you want to tell the deployer R how you want to create those new variables. And in the meantime, you can also create multiple variables at once. So one note is, so if there is already a variable existing, let's say, for price, as a price already existed, and then if you do like change, mutate those, the price column, then the price column will be updated. You'll be replace the old values with your new values. Okay, so here this is example. Let's say, so I have those the diamonds data frame that's from a previous practice. And then so I feel here I create two new variables. One is it's a numeric operation on the carets column. So I take a square and then I take a cube. So those are two variables, new variables I created. And then you can see it here on the print data frame as well. All right. And then, right, so here, so before that, you're creating a completely new variable based on existing variable. So here, I think this is an example also to talk about, different data types of those variables. So here, I'm talking about the clarity variable from this diamonds data frame. So this clarity is, so this is what we call this a factor variable, or it's called the ordinal variable. It's ordinal because internally, if you print it out, you can use levels, call the levels function on this, use diamonds and this $sign to extract this clarity variable and then print out what's the levels of this factor. So that will be 8 levels of the clarity. And then you can also use this like head on this variable, and then it will print out what's the order of those different factor levels. So the I1 will be the lowest and I will be the best, right? And let's say we can turn this the variable into a numerical values. And then here, you can use this as numeric function to change the factor variable of this clarity into the numeric. And the numeric values will be the same as the ordering of your factor values. Let's say the I1 will get a value of 1, and then IF on the best level, we get a value of 8. Okay, and then you can do this using mutate function. So here, let's say I have the diamonds for C, this data frame, and then I want to change this clarity variable from the factor to a numerical value. Then I can use this mutate, and then I'll change it in place. So I'll use the same variable, a name, and then as numeric, and then use the clarity. So this one will, so you can see the third column, instead of those factor values, here there will be like numerical values. All right. Okay, so this is another example, let's say for the price, we can change it to any other currency. So here, the original, it's like dollars, and then you can change it to, Chinese yuan, or other things you want to try it out for yourself. Okay, so I'll skip this one. Okay. All right. So previously, okay, so those are like mutate, filter, and select. And so another thing that we're interested in, so it's very important to get a sense of, what's the range, what's the mean, what's the summary stats of each one of the variables contained in the data frame. And summarize is one of the functions that can create this table of summary stats, which means they can take the vector of your column and then output a scalar. Like say in the syntax here is you can provide it with the data frame, and then what's the function they want to apply to each one of the column. Right, and then so this function, it can be some built-in function from the R, like sum, taking a sum, taking mean, median, or minimum, or max, or you can define your own function as long as the function can take the vector and then output a scalar. So any function that does that can be applied here. And so here, I'm using like a summarize with Z, and summarize with S is also works. That's like a difference between like American and British language. And then so there are like some minor difference between those two, but I think usually if you stick with one and then just use whichever you choose, it's fine. All right, so some examples. So let's say for this diamond, I want to compute what's the average price of all the diamonds I have in this data frame. And then here, you provide the data frame diamond, and then create this variable name, it's called average price, and then take the mean of the price. And then here you will see like in the data frame format, this will only be one value of the mean over all the diamonds you have. All right, and like I said, you can also use your own defined function. So let's say here I'm creating this function of taking a sum of square, to take the function. So this is the syntax. You create this function called SSQ, And then the X is the only input, the argument. And then this function would take the argument X as a vector or scalar, and then return what's the sum of square of this vector. And then, right, and then you can do the summarize, apply this function to the price variable, let's say, and then call it like the SSQ price. Then it will compute the sum of square of those each price value. So like so you can see that this function can be very flexible, and then you can use whichever function you find will be useful to help you navigate the data frame. Oh, right, and then you can do multiple summaries. So at the same time. So for example, like take the mean of the price, and then you can create another variable. It's called the median of the price, and take the median. And then that's and create more to like compare with different sum stats. All right, and then so like I said, so because you can see that for the summarize function, what we have been using it for now is it only return like one scalar value for every column, and also it will disregard other variables in your data. And sometimes we're not only interested, so that's maybe less interesting to you, but more often we're interested in like looking at, group specific summaries. So let's say, for example, like we want to look at what's the average price based on the cut level. So here, this example where this group by function, so this is the next verb that we're introducing here. So this group by function can help you to do this, so for every group, you specify, you can specify which variable you want to group by, and then apply the other functions on within each one of those groups. For example, we can do summarize, and then we can do filter or mutate, etc. So this group by function will be very handy to work with other verb functions in the dplyr package. So let's say, for the example that we showed before, we want to summarize the diamonds by the cut group. So first of all, we'll create this new data frame. It's called using this group by function. And we tell this function that we want to group by the cut variable, all right? And then create a new data frame. It's called the diamonds cut. And then, so on this data frame, we'll apply the summarize function and then create what's the mean of the price and what's the median of price within each group. And then in the output, you can see for every cut levels like fair, good, very good, premium, ideal, you'll have a one scalar value associated with each one of those levels. All right. Okay, and then right, so those are the 5 verb function that we have been go through, like each one of those. And then so I think a very important thing that I find like dplyr or tidyverse, those packages are very useful is you can actually apply multiple verbs or functions in one step. What I mean by one step is not, so previously you can see, we create this new data frame in the first, and then we do summarize on this newly created data frame. Sometimes if you do multiple transformations, this code can be really messy to debug. You can use easily to be error prone. And then, so what the dplyr package provides us, yes.
There's a good question in the chat that I think is worth addressing.
Sure.
What's the difference between a tibble and a data frame?
Oh, yeah, that's sorry. Yeah, I should be clarify that. So the data frame is so if you read in like using a base R function, and then that what we call usually that will be reading as a data frame. And then so tibble is, so when you're reading in, so that's the like a data structure from like the dplyr package. And then the nice thing about tibble is, so I can quickly, so I'll just remember, so 31, okay. I can show you the example that I have before. Right, so here when you're printing out, like say this diamond data frame, they will show you, you know, how many rows, how many columns, and then for every for every column variable, it will also show you the data type, like the numeric, the double, and the ordinal, like those factors. And then you can see this very nicely. So tibble is very nicely in terms of, you know, visualization of the data frame. And I don't think it internally different from a data frame. So you can treat it as a data frame. It's just if you print it out, then it will print nicely. So that's how this tibble is different from data frame. Did I answer your question? Okay, cool. Yes, so tibble is also a data frame. Yes, and then it's just you know, this tibble function will create a nice printout for when you're reading this data frame. So here, this is only like loading from the data. So itself is already a tibble structure. And if you use like functions from dplyr or read R, then like read TSV, those will automatically output the tibble structure. All right, okay. And then I'll go back to where like applying more than, yes, okay. Yeah, so right, so I was talking about you know, if you want to apply more than one transformation, and instead of creating multiple lines of assignment on you know, our older operations and then doing the next on the newly created data frames, this has been addressed by dplyr package, and it's using this pipe function. So you might have seen this before. I don't know if you guys use it in the ggplot yesterday. But the pipe function is pretty much it's taking, essentially it's a transformation on a data frame to another data frame. And I can show you the code in the next slide. That'll be comes very natural to you soon. So so you can think about it as it's an assembly line, right? So what this function does is, so maybe I can use the example here, right? So before we have like multiple lines. So first we do group by, and then we do the summarize on this diamond cut, this newly created data frame. And then instead of creating multiple lines of the code, so here, if you use this pipe function, what you will do is, so first, because the first argument, you probably know this, so the first argument of those functions I mentioned before, like group by, summarize, those 5 verbs, the first argument is always the data frame itself, which means it'll be very easy to put, you know, to pull out that factor in the front and call this, you know, or I just say diamonds specified data frame you're working with, and using this pipe function. And then you can just say group by cut. So because internally that will translate into, you know, these diamonds will be the first argument of this group by function. And the same, this will be happening recursively. You know, whatever you've done in the previous step, if you use another pipe function, and this will be the first argument of this summarize function, and then you can do whatever operations you want to have, right? So this is quite different from what we had before. So you can see, you know, you're doing multiple assignments, and then that's can be really hard to read sometimes. You know, it's hard to disentangle what you're doing with your data set. But here, if you're using PEP, this PEP function, that'll be very clear in terms of, you know, you first do group by, and then you want to do summarize. And then, of course, you can do multiple lines of those operations on the, it's all based on the previous change of this data frame. All right. Right, so this is one example. I have one, maybe two more. So here, let's say, we want to select four C's, those four C's columns, color, clarity, caret. And then, so using the pap function, we can feed in, using the diamonds and pap, and then select those four variables. And then in the next step, let's say I want to do filtering to subsetting the rows based on, I want to keep only those finest diamonds. And then I specify the logical arguments here. And then this first two lines, the output will be the argument of the first disposition at the filter function, right? So you can do multiple things at one step. All right. And then, so, okay, so this is like a connecting back to yesterday. Maybe you guys have been using like ggplot, and here the pipe function is also very useful here. You can first do some transformation on your data set. Let's say we filter to only those finest diamonds, and then later on, I want to create this called the scatter plot of two variables against each other. I'll put the price on the y-axis and caret and see, how the price change with the carets from each diamond. And then, so here, this is the join point, it's just a scatter plot. And then if you want to add like a linear regression line, you can use like a geom smooth and then specify using linear model. And then this will be like the fitted linear regression line. And then, yeah, you can put to put it nicely in a theme, using themes like black and white. There are other options. There's like a whole bunch of options for like using ggplot. Okay. Let's see. Right. Okay. So today I only have like a limited time on like those word functions. There are other useful functions. For example, if you want to merge, let's say two different data sets, you can do like inner join, like different types of joins based on if you want to do like keep. It depends on which kind of rows you want to keep, and then those are different options like inner, left join, right join, anti-join. And then other things, for example, sometimes we want to create like a data frame from wide to long or vice versa. So this can be a little bit hard to visualize in the first place. So you might have to, there might take some practice to get your head around this. But usually there's sometimes there's a need to transform the data into this kind of data format, but I won't be getting into so far today. But if you guys are interested, those are very useful for your later analysis as well. So I can provide more resources at the end, and those tutorials or online resource books that can talk a lot about those functions. All right. All right, yes. So these are the resources you can look up. Like the first is the Tidyverse online website. And then there are other very nicely written like cheat sheet that you can quickly look up those functions. They have this like visuals, like how data transformation has been done, to clearly explain what is like a different join, like inner join, anti-join, or full join. And there's a very nice book. It's called the R for Data Science. And then, so there are many chapters that'll be useful for talking about like data wrangling. All right. Okay. Is there any other question we want to address here before we moving on to using HPC? Let me check. Again, the slides will be posted on the GitHub page, and then you will make sure you have those after the class. Okay. If not, then I'll move on to another topic that I want to touch on today. So the reason I want to bring up like HPC, where it's called the high performance computing, um, well, I guess some of you might have some experience and maybe the majority doesn't. But I find so I have been like doing genetic studies throughout my PhD life, and then I've been dealing with, large data sets up to like, I don't know, like 10 gigabytes or like 20 gigabytes. And then, you can do like heavy computing, which is very hardly to be achieved using your own PC, your personal computer. Like say I'm using a Mac iOS system, and then let's have a memory of like 30 gigabytes. And then that'd be really hard to read in the data frame for large data sets. And that's why, because, we have like a very limited computational resource on our own computers. And here, this the HPC, the high performance computing is here to aggregate, more resources, that cannot be achieved by your individual computers, but they have more like specifically highly specified to do like highly computing, what we call those nodes, like computers, into a cluster that they can work together to perform this advanced and specialized computing jobs. So the way that you can see it is, so for example, we have our own laptops, you're working at home or in a classroom, and then there's a cluster. So it's also, those are multiple like little computers that doesn't have the screen as your own laptop, but there are like highly specialized, those are like cores of doing, processor units or either CPU, GPUs. There are like hundreds of those like sitting in a room. And then, we can use the internet or networks to connect from your laptop so that you can use those resources from those computers from your own laptop. So this will be very useful when you're doing your research work, either for your like graduate students, master students, or PhD students. All right, and then so we have the HPC is hosted at USC by CARC, which is shorthand for like Center for Advanced Research Computing. We call it CARC. And then there are many resources they have provided to students, to researchers, how you get connected to the HPC, how, those like tutorials, introductions of what they have, what kind of resource they have. And then they also provide workshops and weekly office hours. So they can be really helpful and to help you out, if you any questions, any troubles that you run into, and then they can be very responsive. All right, so first I want to give you an overview of what kind of computing resources we have and what is the structure of those like HPCs. So here this is like a little diagram, and here we have the users. It's like me and you. We're sitting in front of our own computer, and then so I'll show you later on how we get connected to the HPC. But in brief, the first step we'll do is trying to log in from our own computer and then log into what's called the login node, which is the head node from the HPC. And then the structure is, so the login node will be handling all going into this, the first step of your login to that HPC system. And then there are other like different nodes responsible for different functions, right? So here, for example, there are like hundreds of 500s of compute nodes sitting like wired together. And then there's a separate like shared disk or file servers, and those are separate from the compute nodes that only responsible for storage of your files. Right, and there's there's another like, we have so many resources, so many CPUs, GPUs, if the users asking, I need like a 50 gigabytes, what's the priority of, I asked 50 and then maybe Dr. Street asked for 100 gigabytes. And then, there will be like a Slurm job scheduler it's a computer, it's not a person, it's a computer program that can, handle, how to allocate those resources to different users and based on, based on your request. And then, so generally, there will be two different clusters. The first one is called the Discovery. So that's free to all graduate students at USC. I'll talk about how to log in, using your USNet ID. And then there's a separate, it's called the Endeavor cluster. So that's like more private to like a small specialized group. So for example, your PI wants to separate, only use those cluster within the group so that you don't have to compete resources with all other students across the campus, including the HSC campus and the UPC campus as well. So, if you paid like a 1 year per, I don't know how many dollars per year, and then you can, those separate nodes will be only for you. So yeah. All right. And then, okay, so like I said, if we want to use like the HPC system, I think everyone here should be able to get access to at least get onto the login node. So here, you can use your USNet ID. Let me see, what's my last slide? Right, and then the thing you need is you have to have your USNet ID so that that's part of the command you will use to log in the system. I'll show you when I get back to the shell scripting. And then some requirements if you want to connect to the HPC is if you are on campus, then you have to connect to this USC secure wireless network. And then if you're off campus, they will have to get your device connected to the USC VPN, and then you can log into the HPC system. So there's like a safety concern. So you have to use the school resources, you have to use the VPN. All right. And then, finally. So how we get onto this like Discovery login node. So I will talk about Discovery. This is very general. That's any graduate students, I think, can log into this the HPC using this command. So so what we are using, I know maybe not all of you are like familiar with using like shell scripting, like this is called like the shell command line interface. So if you're on Mac system, iOS system, this is the app called the terminal. And if you're on like a Windows system, you can open like the Open SSH or PuTTY or other softwares, and then type this command. I can show you. Let me see. I can maybe quickly how we're doing on time. Okay. All right. So if you're on Mac system, you can try search like terminal, right? I'll make it bigger. Right. And then, so this is called the shell. And that's like the interface that you can work with, you can do anything actually with this shell scripting. You can open files on your computers. You can navigate your file system. I know we usually, click around and then open the app, open like a file, open a picture. And then whatever you do with your clicking, you can essentially do with your shell scripting. Right, so here, for example, I'm listing what's the directory in my current working directory. And then, okay, let's say if you want to connect to the Discovery HPC, then we'll type like SSH this is the command for, connecting to like other servers. And then you will write down your UI scene ID, which for me is this. And then you can type at discovery. This is the host name, usc.edu. And then it will ask you for your password. And this will be the password to whenever you log in to your like you're using USC Net ID. That's the password. That's the only password. And then okay, so I'll type. So you can see when I'm typing, it's not showing up. It's not wrong. That's how it is. It's like protection for your safety or for other reasons. Right. So you can keep typing. It's just it will not show up, but whatever you're typing will go in there. Right. And here, let's say, okay, this is the login page. If you're successfully, your password is correct, then this will be the page you see when you're getting onto the login node, right? So here, this is you're on the discovery 2. And then this will be very similar to, this interface is very similar to what you have on your personal computer. Right, and then do the same thing. I can show what's the files has been listed in this like a login directory. I can show what's the name of my current directory. All right, maybe I can go next slide. Okay, so there's another way that you can interact with the HPC. It might be easier for beginners if you haven't have any experience with the shell scripting before. They have this like an online. Oh, maybe it's not. So I think I have somewhere. Oh, maybe not. Oh, here, right. Okay. Yeah, I want to show you this real quick. Okay, so here, this is the address I provide you, and then you can log in to, this is called the on-demand. So that's like a graphical interface for HPC. Right, and those are the different file folders. And then, you can, right, those are the two clusters. I talked about a discovery endeavor. And the one that we just logged into is the discovery cluster shell access. You can click on that. And then that can easily get you into, the same interface that I log in using my terminal app, right? Right, and you can also open different files, using, your this interface. You can do downloading, uploading, or any other operations you find is useful. But I personally, I would highly recommend if you guys, get familiar with this using this this shell scripting, this interface, because your computing will be pretty much largely like over 90% will be based off, using, using command line tools on this shell scripting interface. All right. So here for now, let's say we have successfully logged in. And if you guys don't, I think there might be the first time you log in, there might be asking something that's an authorization or something, and then you can click yes. Right, and then so later on, if you try it out yourself, if you log into here, I'll try to explain, these are like different directory available to you. So first two is those are already created for you the first time you log in. The first thing is you have a home directory. All right, so this is this one. It's home one, and then your USC ID. And then there's a scratch directory that's for I'm not sure how many storage there are, like maybe terabytes or gigabytes. That's available to like scratch. You can do computing in the scratch directory as well. So the command that you move into, to the scratch directory, you can use like CDS. That's a very quick command to change directory to the Scratch folder. Let's say, the Scratch, and then that's my folder. All right. And then, so later on, if you're working with a PI at UIC, then they will have their private project folder, and then that will be in the form of, the directory will be like the project, and then your PI like username or project names. So for example, I can show you. So for my PI, Nicola Mancuso, so we have like a project folder, and then that's under his name. And then so everyone who has the access to this group is being added by your PI, and then you can use the resources that's allocated under his name. So for example, how many files, what's the storage size you can have, and like how many like computing resources you have. So yeah, so that's pretty much it. All right. Okay. Right. So here I listed out some, very common useful commands when you're, working with this shell command line tool. So for example, the pwd, like print working directory, this is your current directory. So this is where you are locating yourself. And then you can change directory, using cd. And then plus, what's the directory name? Like say, we can list what's the current directory available. And then you can change directory. Like say, I change to my directory. Right, and then here, this is my directory. Right, and there are others, you can try it out yourself. I think that's pretty much what I've been using like day by day. And then, like, creating new directory, changing existing files, change names, copy files, remove files, print those files. Those are like commands that you can go through by your own. And if you have any question about, you don't know what this command has been doing, and then there's like a man command for every one of these, I believe. You can click man, this shorthand for man menu, and then give it a name of the commands you want to look for. Like say, I don't know what this last function has been doing, and then I can print out what's the menu for this function. And this will tell you, there are some example, I think. Right, so the last function is to give you, like to navigate the, okay, I can show you maybe. Let's say I change directory to R Bootcamp, and then I can use this to show, like say I want to open up this like a load data R script, and then you can look at here. So this to show the content of the file. All right, okay. All right, okay. So with that being said, okay, the first thing first I want to remind everyone here is because so here, okay, let's say this is a login node where after you type like SSH and then you're successfully authorized, and then this is the login node where you step onto the HPC system. And the very important thing is, so everyone will be arriving here first. And then here is only for like very simple, file system, checking your files, checking your folder directories. And if you have any other, if you want to do like a reading data or like doing like heavy computation, fitting like Bayesian hierarchical models, please do not run any of those heavy loading code on this login node, because it can be, the traffic can be really bad for other people, because we're sharing, you can think about, we are sharing the same computer, and every like thousands or hundreds of thousands of people are using it. And then if you're using too much resources, that will block others, that'll be very slow. The system will be drive down. So that's why, if you have any other, you want to load in data or you want to compute anything, a very simple step is we'll request interactive node, okay? So because we have, 500s of the compute node we can use. And then here, this setlock function, this is like a slurm allocation. So the setlock function, you can use this, I'll type setlock, just make it quick. All right, so I use this function and then I tell the Slurm scheduler that I want to use this node for like 2 hours, right? And that's a time limit. And then I want to like a memory per CPU to be 10 gigabytes, right? And then, right. And then here, it would tell you, okay, you want this, and then I allocate these resources to you. And then there's a job number. And here, one thing that you see will change is, so this is the compute node number. So previously I have, this is just a host name, right? This is a discovery 2. And after you have requested node and they have allocated this node for you, and then you will change the compute, you're no longer on the login node. You will jump into another small compute node. And the index for that compute node is this number, right? So you're on like another computer right now. And so right now you can do whatever, computing or reading data, as long as your resources is asking. So for now I'm asking 10 gigabytes. And if you're reading in, like say, like 20 gigabytes data files, and that will kill your job, and then that will, send you back to the login node. And then you can request more until you can successfully read in your data. So yeah, that's the compute resource you're asking for. All right. Okay, there's 1 minute left. Okay, so here, just real quick, I think only 2 slides. Okay, so here, we can use different softwares on the HPC. So HPC, they provide like R, provides Python, provides like a variety of softwares. They have been pre-built under their system, and the way that we call those call the R on HPC is, so this called this modules. So first of all, you can do module purge, which is clear out all the loaded modules for your current session. And then I'll just, for the sake of time, I'll copy this. Right, so here, this is loading different required package to use R, but let's say we want to use, so there are different R versions that's pre-built by the HPC. So for now, I'm using the version 4.3.2. And then, so these are the required package that need to be loaded, right? And then you can use the module list to see what's the current loaded modules, like GCC, OpenBLAS, R, right? So those are the 4 things that we loaded. And then you can type which R to see, which is the R software that we're using, right? So this is the pre-built by the HPC, the CARC department, right? So this is using R 4.32, 4.32. And then this is the R that we'll be using, right? And you can type R, they will automatically load. So this is called R console, right? So previously we have been using R Studio. That's very nice interface, like graphical interface for using R. But for using HPC, we'll have to use like this R console. That's that you can do everything. You have to write your script. So every script you have been writing on your like R Markdown files, it can be run in the R console as well, right? So like, right. Okay, so for example, I can load, I guess I'm not sure if I have tidyverse, or maybe I don't have tidyverse. So, okay, so if you don't have any package, you installed, you have to install the package using the same command line tools, like install package, like a tidyverse, and then go through the steps that's needed. I'll just cut it off. All right. Right, and then if you want to quit this console, then just type Q and then not saving image. All right. Yeah. And then so installing our package on HPC can be a little bit of pain. And we have someone, from our group, so Siran, she has been working with our HPC for long, and then she has kindly provided this website. If you have any question regarding our installation on HPC, there are many people have been experienced before. So this is like a nice like a website. People will post their question, and then there are people who answer the question. So yeah. All right. Yes. So here, this is like the demo. If you can. Not sure if I have a ggplot deployer or. Oh, I have deployer. Okay, and then ggplot2. Okay, and then the same thing. The diamonds data set. Right, and then you can print out what's the diamond data, right? So those are exactly the same output that we have been running with RStudio. Okay, I think this is the end, and then right. So there's other, you can also use use Slurm scheduler to run your R script. So what we have done for now is, we're call R. This is a command line, and then this is the R console. Can run it interactively. And then the other way that we can write R is, we can write up our script. I already write this. So this is called a load R. You can see this. I'm loading ggplot2, the diamonds data set, and then print it. All right. And then another way to run it is you can call like R script and then give the names of the script they want to run, right? And then this will do the exact same thing. When you're like trying those code interactively with the R console or using like running those code in the RStudio, right? So those are different ways that you can run your R code. And the Slurm is, you can run this job. I can run this R script job like using a Slurm package, using the Slurm scheduler, which is you have to write out like a shell scripting file. This is called the run R. I call the run R like .sh like for shell. And then those are some required headers that I can also share with you, or there's like I think their website have these headers already, right? So those are headers that can tell the Slurm how many, how long your job will be taking, like a maximum of 1 hour. And then what's the resources, 8 gigabytes, how many jobs are running, which partition. You can also email yourself when the job begins or when the job is done, and then run exact same those commands, and then the job will run like R script then to execute this R file, right? I don't have time for that, but there are some tutorial on the Kark website. So I put it on there. So if you guys are interested, you can also look up those files. All right. I think that's it. And is there any urgent question before we go? Oh, if not, then thanks everyone for attending. And if you guys have any other question, you can feel free to reach out to me or to Dr. Kelly. We're very happy to take any question and help you along with this. All right. All right, then that's it. Okay. Thank you all.